Now we're gonna focus just on the vis.gl ecosystem. This year, all of the submodules got some minor or major updates, and most noticeably, we have new map wrapper packages that were released. Now we have 3 wrappers for Mapbox, MapLibre, and Google Maps with really nice API alignment. I'm gonna talk about that later. vis.gl 9.2 was being worked on really hard for almost a year, and we just released it. I will let Felix talk about the exciting web GPU improvements in this new release.
Huge slide. Yeah, so this slide is just showing the A5 layer, and also I think Xiaoji made it her favorite holiday destination in the Bering Strait. It's also a new example right here, right? This is where you go on holiday. No?
I made it.
Yeah. Oh, it was Chris. I said that's where you go on holiday. Yeah. So this is showing the A5 layer. It's also part of a new example that we have on the website showing the differences between the different grid systems. But the main thing I want to talk about is Web GPU, which is a new API in web browsers that's been around for quite a long time. But it's just getting to the point now where it's available in pretty much all the major web browsers, as this slide is showing. In some of them, you have to enable it with some kind of hidden flag. But in Chrome, which has a big chunk of the market, it's enabled by default. And we have been trying to basically port vis.gl to use Web GPU and WebGL in parallel. Some of the reasons for this is that Web GPU being a new API, then it works much better with the current architectures of the GPUs that are available on the market now. So it's going to give you better performance in general. But the kind of main reason to do this is to unlock some of the more kind of modern features that these GPUs now support. So some of these things were things that were kind of possible with WebGL, but the performance wasn't so good, or you had to hack it in some way. So, for example, you'd have to use like a texture to do kind of computation on the GPU. But Web GPU now is giving you compute shaders, so you can do much more kind of interesting visualizations, kind of think like those kind of like fluid simulations or those wind maps where the particles are moving around. Then these kind of things are going to really sort of push what we can do with vis.gl. A lot of this work has been done in LumaGL, which is the low-level framework that basically powers vis.gl, and also in the future, hopefully, more applications. I think maybe we're going to have some update on that later. And there's a couple of new features which are being driven by the sort of requirements of web GPU ways of doing things. But what we're trying to do with LumaGL is essentially make one unified API that abstracts this difference between these two APIs for you. So we're going to have a way of doing async picking, which is already shipped in vis.gl, but not enabled by default. There's been a big refactor with the texture class, where it's now much simpler, and all the async handling of downloading data is now split out into this sort of extension wrapper async texture class. As you'd expect, a bunch of bug fixes and just general improvements of the API as we integrate this into vis.gl. A bunch of texture, vertex formats, all this kind of like bookkeeping, getting us closer and closer to having the kind of full API implemented. And the examples now on the Luma website, you can now switch between WebGL and Web GPU, which is pretty cool. At a high level, when we're looking at vis.gl, then the kind of plan that we've taken is to try and do it step by step, so we don't have too many big breaking changes. In 9.0, then we basically migrated in a big migration the core of vis.gl to work with LumaGL, which was moving to a more web GPU-like architecture without actually enabling WebGPU. So we're basically trying to expose the WebGL backend in a way that was more WebGPU friendly. We then followed this with updating all of the shaders in DeckGL from an older version of the shading language GLSL 100 to GLSL 300, which is kind of shifting from WebGL 1 to WebGL 2. In the process of doing this, we dropped support for WebGL 1 because it was just too much to handle. And in 9.1, we then migrated the way we communicate between the JavaScript code and the shader code to a method called uniform buffers, which again is more in line with how WebGPU does things. So right now in 9.2, we have finally shipped 3 layers, which is really, really cool. So great job here from Ib and Chris Kapp on getting this over the line. I think it's point cloud layer, line layer, and scatterplot layer. And this is like a really, really great basis for getting to the next minor release 9.3, where we hope to do a porting of all of the layers in the layers package. And then we're sort of really getting closer to having this like truly ready. There's some plans in 9.3 of Luma to have a general purpose GPU module. So this is a way that we're going to basically have an API for exposing compute shaders that we can use in Luma and in DeckGL. And if you want to try WebGPU in DeckGL, it's pretty simple. You just have to, when you're setting up your DeckGL object, tell with a couple of props that you want to be using a WebGPU adapter. And then, of course, it's only going to work with a couple of the layers that we've ported so far, but you could also use, you could rewrite your own layers in WebGPU in principle to use this adapter. Now, in the future, then this is going to be something that's going to be hidden from users. So you're just going to set up DeckGL, and it will then automatically, underneath the covers, have a look what is available on the user's computer. And if they have WebGPU support, it'll pick that adapter. And if not, it's going to fall back gracefully to WebGL 2. But of course, we need to actually ship all of the layers before we can do this. Otherwise, we'd have a lot of broken applications. So yeah, I think that's all the slides on the WebGPU updates. So next, I think is Ib on the exciting new widgets.
Okay. So, sorry. So as part of, some of you have been to these events in the past. I think it is the 4th time we have one of these big, summits, and as part of these, we also a big reason for these events is also to get the feedback from the community. And one of the kind of strongest pieces of feedback we got is that when building applications with DeckGL, it would be really useful to be able to have some controls that can sit on top of the visualization, and so that the application doesn't have to spend so much. Writer has to spend so much time implementing these things, and especially controls, little buttons and widgets and so on, that they kind of interact with DeckGL could be pretty tricky to create in the past. And so in the previous release of DeckGL, we did launch a new widget system, and we only had a couple of widgets there. It was more kind of a demonstration of what this could do. And then we've done a big push in 9.2, which is, as Xiaoji said, has just released this week, where we have a big new library of widgets. And so this should start to become really useful, and it'll be really good to hear from the community. So if we start, just to get everyone grounded, and maybe some of you have played with the widgets in 9.1, but if you haven't, then if you're familiar with how to use Deck, you create an instance of Deck with, if you're using pure JavaScript, you basically calling the constructor new Deck, and you give it a list of layers. So you can create like a JSON layer, an arc layer, and so on, and pass all of those in, and DeckGL will render them, and it's a declarative list. So it will, diff the layers if you change them and automatically update everything under the hood. And now there's a new top-level prop on DeckGL, which is widgets. And so in the same vein as layers and views, it takes an array of widgets. And so you have this library, this growing library of widgets now that you can use. And basically these then put little HTML components on top of your visualization that then can interact with your map. And all of this also has React bindings. If you're in the React world, there's component wrappers for all of these. So in the lower example, you can see how you create a DeckGL component and then a layer component, and then just adding a compass widget as a child of the DeckGL component. Now, so obviously all these widgets, they build on a common infrastructure. So inside of DeckGL, which you don't really see as a user, there's a widget manager, and the widget manager manages objects that are subclasses of a class called widget. And so this is basically the kind of the prototype of the widget. These are the different methods that it has, and you can see these that are kind of outlined here or highlighted here. They are lifecycle methods. So these are the ones that the widget writer with subclass. You can see here the FPS widget. And we're going to come back to that one. These are fairly straightforward. They're also documented. So when the widget is added and the widget manager sees it, it needs to create like an initial DOM element that it can attach to the DeckGL canvas. And so it has an onCreate root element. And then when it actually gets added, then there is an onAdd where the widget can kind of adjust its state or create any resources it needs. If it's removed, then there is an onRemove, and you can do cleanup. And then whenever it needs to be re-rendered, it goes an onRender HTML. And you basically update the DOM under the root element, and that can be done in different ways, as we can see. And internally, if the widget updates its state and it realizes, so the widget manager will call update the HTML when it sees that things have changed, but the widget may also do things that requires an update, and then it can explicitly call update HTML. So this is kind of the current set of methods. So there's a few more, but we're going to maybe look into roadmap and so on later, that there's still more that can be done to improve it. So let's look at this. This is one of the smallest new widgets, and so it basically just shows a little indicator that shows the current frame rate, frames per second. So by adding this widget, and you kind of navigate around and move around, you can get a pretty good sense for the performance of your application. If you add a couple of new layers, you can see if the frame rate drops. You can try different layers, different changes. And so it's a pretty common thing to have in these type of frameworks. And as you can see, it basically just declares its props. It takes the widget prop, imports the kind of default widgets props from DeckGL 4 and adds a few, and then the class basically extends widgets with those props. And in the constructor, kind of initializes with the initial props, and then has a set props method that kind of needs to do anything extra that base class doesn't do. Then you can handle those new props there. The superclass is set props. And then if you need to do something on add, and in this case, you can see that since this is an FPS widget, it's going to want to continuously update the FPS value. So it starts a timer, it calls request animation frame. And then in the render HTML, when it comes time to update in the root element, here we actually use, it looks like React, but this is React. So in the built-in, you could of course create, just use JavaScript to create the DOM here, but we like the we think the readability and maintainability of having JSX is easier, but in the end, this doesn't create any dependency on React. It's completely internal into the widget. So there is a little bit of small libraries. It doesn't cost us too much to have React in here. And and then you can see that this animate callback that's called them, hopefully, hopefully 60 times per second. That's it. Rendering it slow. It updates, gets the FPS, basically updates the value, updates HTML, then registers callback again, and reads this. So deck historically has it collects a number of metrics, and one of those is an FPS counter. So it doesn't really have to do any additional calculations here. It really just reports the deck.gl value. So really kind of a one-page widget that is still very useful. So yeah, and to make it easier, we've also created a number of React components that are available from the deck.gl widgets module. So if you create your custom widget and you need something like a button with an icon that is styled and participates, these widgets support theming. So by doing it this way, you get to write very easily a widget that participates in the kind of deck.gl theming system. And so you have a couple of choices. You have a button group, grouped icon buttons. You have a drop-down menu, an icon menu. There's a couple of components we offer at this point to simplify things. Of course, one of the kind of biggest use cases for widgets is in Python, because in Python you can't really write easily your own. You can't really access the DOM very easily. And so to be able to, adding these type of components, it's easy to create a deck.gl visualization in Python, but adding these type of extra components can be quite hard. So we put extra effort into, and we have a great community contribution to also to allow custom widget libraries to be added. And now you can see in this basically just create pdk.widget, and then you do pdk.deck and add the widget prop there, just as in the JavaScript version. Now you get a nice button on your visualization.
Yeah, so I'll do a quick tour of the new widgets that we added in 9.2. And as I've said, these widgets all work in the Python environment in PyDeck. They work in the React environment. They work in the Vanilla.js environment. Pretty much every environment we have is compatible with these widgets. And that was really important to us because that was kind of the main request people had. Like, we want to quickly be able to add controls and things to environments that we're working in. And we want you to meet us where we're at. But we also want to be able to make our own. And so we have a custom widgets environment where you can go in and inject widgets that you create custom into the framework. So you do not need to open pull requests to Deck to add new widgets. That's kind of what Ib just showed. So, but we also would love a nice rich library of like officially supported widgets. And we added a bunch in 9.2. And thank you, Ib, for adding most of these. There was a couple of weeks where he was just boom, 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 new widgets. So here we go. The first two are navigation widgets. One is for resetting a view. It's a button where basically you set the initial view state prop on Deck. And when you click the button, it will return you back to that view state, right? Very simple. Gimbal is for non-geospatial views in Deck.gl. So we have a lot of non-geospatial users in addition to the map ones. So if you use an orbit view in particular, you're going to find Gimbal very helpful. So as you orbit around, you can see that rotation and then click it to kind of reset. That complements the existing compass widget we have for geospatial. And then some new view widgets. So one of the very common things that people would like to do is, when comparing a map is being able to set up, Deck already has this like multi-view system where you can set up side-by-side maps or different views to have a look at things from different angles. But, they would like to maybe look a little more on the one on the left or a little more on the one on the right. So we have a splitter widget now that basically adds this like draggable slider down the middle. View selector is basically at this point just a drop-down helper. But you can kind of see you click on it and you can set up in your application kind of maybe a vertical or horizontal view. At this point, it's more of a helper. It doesn't do this internally for you. You kind of set it up yourself, but it's nice not have to make the icon yourself. Scale is kind of like a Google Maps scale indicator, very classic cartography thing. It supports kilometers and miles with a prop. And then geocoder, probably the most powerful new widget we've got. This one is really nice. It allows you to bring your own API key for Google Maps, Mapbox, OpenCage, but also if you do not have an API that you want to use in your app, you can use just type in coordinates and it'll navigate to that. Or you can use the browser's current location API as well, and it'll navigate to that. Info widget, this one is probably the most commonly requested widget. It's basically the helper widget that can, if you click on something on the screen or hover on something on the screen, you want to be able to define some custom HTML that you want to be overlaid on deck. And so info widget is the one you use for that. Context menu is the same thing, but for right-clicking on an element. These both integrate with DeckGL's picking library. So whenever you hover or click on something that is like a DeckGL layer, it'll actually go and pick that element in the map, extract it, and then give it to the widget. So you can put things like properties in your scatterplot layers or whatever. And like you see here in these airports, those are actually being pulled from your DeckGL layer data back out. So you do not have to kind of manage that yourself. The next one, utility widget, very basic screenshot, right? We all want that. Plotly had it for years in Python, and now we've got it in PyDeck. Theming, so being able to toggle between light and dark mode, or if you set up your own theming with our DeckGL system, you can kind of control the theme with that. And then some utility widgets, right? Frames per second, we saw that earlier. You can kind of see the frames going from 120 down to like 40 when we have the Google 3D tiles loading in new tiles, right? It's pretty performance intense. And then there are tons of other stats in DeckGL, Luma, ProGL, or you might have custom performance metrics that are important to you. We have a nice little stats menu you can use that we imagine will be used mostly during debugging, but it's very helpful. And then the last utility widget we have is for loading. DeckGL has asynchronous layers. You can just throw a URL onto many different tile layers and it'll do, tiling for you internally. Or if you throw like a JSON URL onto a random layer, DeckGL will go and actually fetch that data. Utility for the loading widget, just whenever it sees that Deck is loading something, it just puts that spinner on there so that you know that it's not broken. It's just loading. And then the last one is a timeline widget, which is a very simple kind of like animation, play, pause control, time slider control, where you can configure things like time range or the step interval or the play speed. Stylistically, it looks very basic. It's just like an HTML slider built in right now on a button. But we really want to see what people want from this one in particular, and we want to hear feedback on what the timeline widget should become. We have Kepler GL for years has had an amazing timeline. We have some Deck examples that have timelines built in that look a lot better, but for now the widget is super basic, and we'd like to hear where to go with this. That's widgets, and I think we're going to pass it over to Xiaoji next to talk over some community things. But I'm also looking at the time, and we are kind of running short, so we might have to speed through these.
Yeah.
And
Sean is going to talk about the Kepler specific updates. I think one of the most exciting is the integration of DuckDB and the SQL Room core components into the library. RecMapGL, we recently did a code split between Mapbox and MapLibre wrappers. A little history about RecMapGL is it used to be just a Mapbox GL wrapper. And then MapLibre came along as a fork initially from the Mapbox v1 library. So we said we also supported MapLibre, but then the two base map libraries continue to evolve, and the API started to diverge, especially after they both added TypeScript support. There were a lot of plumbing just to try to share common code between the support for both libraries. And MapLibre eventually added some hooks for us to be able to do the reactive camera state control. And we decided it was time to just split the code base and have dedicated code for each one. So now RecMapGL is basically a master package that just redirects to these two sub packages. And the MapLibre wrapper now has a better state injection support than Mapbox because our deep collaboration with the MapLibre community. The Mapbox wrapper had a rewrite, and we tried some different approach. And instead of having two camera state transforms and swap one of them in at the time of rendering, we tried a proxy approach where we'll just intercept state changes and do things accordingly. This is all released in 8.1. It's supposed to work better for both Mapbox and MapLibre users. And React Google Maps will have the contributors talk about it tomorrow. But in the past year, have some really nice updates for server-side rendering support and TypeScript. Loaders.gl. There has been a lot of work on the data source API. It's basically an abstract interface that exposes different backend or server protocols that tile or serve content dynamically to the front end on demand. And there is an aspiration to create a DeckGL layer that would render any implementation of data source, regardless of its PMT, MVT, or WMS. I believe there is an experimental layer in DeckGL communities repo that work with some of these. The DeckGL community repo is where we put the experimental components that are not quite ready for the main library, that maybe we're not quite ready to commit to keep it working at all times at every release. But it's something that we feel has potential and we want to get feedback from. This repo has grown significantly in the past year. We have a set of layers that natively support arrow format. We added InfoVis layers that mostly work in the non-geospatial space. Also graph layers that render network visualizations, raster layers that work with satellite imagery. And we have the editable layers that was ported from the old Nebula.gl code base that supports editable GeoJSON. Do go take a look and see what suits your needs. And we want maintainers and we want feedbacks. So we know what components we should invest in and what to graduate next. Last but not the least, operational security. There has been rampant supply chain attack on open source software and on the NPM registry. OpenJS Foundation has funding and security resources that are actively help us review our publishing setup and instant response plans. And we are really grateful that we are part of a organization that is able to handle this kind of things and keep close eyes on attacks and make sure that we're well prepared for it.